All right, continuing with chemistry, everyone's favorite non-anatomy science. All right, atoms. All right, atoms are the smallest possible unit of matter that still retains the physical and chemical properties of its element. Meaning, if I have one atom of carbon, it's still carbon. All right, so it's the smallest thing you could have, and it's still carbon. All right, it's not broken down into something else. Can I take atoms and split them off into their smaller stages, the subatomic particles? Sure, but it's no longer that atom. So, for example, if I take carbon and take away its protons, it's no longer carbon, right? So, with that said, an atom is the smallest unit. What are atoms made of? Subatomic particles. That's a fun way of saying sub, under, small, or under, atomic. What's under the atom, right? What's under the hood? Okay? It's not just an atom. Ooh, magic. No. There's something under the hood. What is it? There are three subatomic particles. You have neutrons, which have no charge. They're just neutrons, right? They're there as filler to make sure that your atoms stay combined. They're kind of like a glue. Think of it that way for this class. Protons have an electrostatic charge, and it makes them slightly positive in charge. Electrons are slightly negative in charge. These are going to be really important later in the year when we talk about different electrochemical gradients. Um, Really, we're going to talk about like how do your neurons work, right? It has to do with charges in the body, right? Remember, right? Your neurons send electricity, right? So we'll talk about that stuff later. But that's important to understand positive and negative charges. And you can see that here. Neutrons and protons. Neutrons are neutral. Protons are positive. Electrons are negative. As you can see, we're not going to go into the nitty gritty here. All right. It's important to know this stuff, but I'm not going to go into ultra detail like a chemistry class would. Here's some things to understand. I'm going to let you guys look into this a little bit more on your own. Atomic number versus atomic mass. You do need to know the differences between these two things. So all atoms of an element have the same atomic number. The atomic number is the number of protons. Okay? Example, sodium. Sodium's atomic number is 11. Always and forever, it'll be 11. If you change that number to something else, you will change the element to something else. That is key. That is huge. Sodium is forever sodium when there's 11 protons. Can you change the number of neutrons? Yes, it is still sodium if you change the number of neutrons. Can you change the number of electrons? Yes, you can change the number of electrons, and it's still sodium. Key here is atomic number is the number of protons. Here's my example of remembering this. Think of it like a sports figures number. My example that I use, and every year less and less people know it. Who is number 2 on the New York Yankees? Anybody here who knows anything about baseball or the Yankees? You would say it's Derek Jeter. And that is correct. Tell me the last time Derek Jeter walked onto the field wearing number 35. Right? It's his number. The atomic number is the number that's assigned to that element. Jeter will always be number 2 for the Yankees. No one else. Just like with sodium here, it's 11. What the heck then is the atomic mass? Atomic mass is how heavy or not. What's the mass of that element? The mass is comprised of two components: the protons, which is your atomic number, and the neutrons. Okay, those two things are going to account, not the electrons. So with that said, 23 is sodium's number, right? My question to you is, how many neutrons are in here? How do you do that? You take 23 and subtract the number of protons, which, as we mentioned 2 seconds ago, is 11. Right? And that's going to leave us with the number of neutrons. So atomic mass is protons plus neutrons. Okay? Again, please use this as practice. There's a couple examples here. Right here's like an example, right? So do out the math here to figure out the differences. Here's some of the numbers, right? It should be 12. If you do it with the carbon, if the mass is 12 and the proton, the atomic number is 6, What is 6 minus 12? Or 12 minus 6? It is 6. So that's the idea. That's how you figure out those numbers. Rewatch that part of the video if you need to help you understand it. And here are some of the elements, the atomic structure of some of these elements. All right, cool. That's the end of this video.